Hi everybody, this is Tor Storley and I am back with another video. In this video, I will be showing you how you can create a financial calculator in the Rust programming language. Now, the Rust programming language is a compiled programming language. So in other words, it's created as an executable with binary code, and hence the speed difference between an executable created with a binary, binary format compared to an interpreted language like JavaScript or Python is going to be magnitudes of speeds. And the Rust language, therefore, is super fast. It's actually, in some cases, faster than C++. And C++ is one of the fastest languages around. The problem that C++ have is that unless you really know what you're doing, it's a very scary language because you can really have access to the memory space that your program holds, and you can really screw up a lot of stuff because you can corrupt, you can destroy, you can accidentally overflow memory space in your programs. So C++ is what you call a user-controlled memory language. In other words, you are responsible for what you're doing. So you better know what you're doing. And even seasoned programmers who use C++, they are scared of using it because of that particular problem. Now, Rust doesn't have that problem because they have used a lot of the concepts you find in C++. I've seen lot of similarities there. None of them has what is called a garbage collector, which slows down a lot of these programs that you see, like C#, like Java, etc. Because they use garbage collection, which make it safe for you to use them, but it also makes it slower. Right now, we're going to look at Rust, and I want to talk a little bit about Rust because Rust has solved a lot of the problems that C++ have with the memory management. Now, I don't know Rust that well, so I'm not going to talk a lot about it because, you need experts to talk about these kind of languages. What I happened to do, though, is that I looked at Rust for about 3 days, and I was able to create an application in Rust that actually works. So I'm pretty proud of that because Rust has a reputation of being a very difficult language to learn. And it is, because there's a lot of syntax in there. Once you get a little higher level, it becomes really hard to understand what's going on. Now, but at the lower levels, the basics, there's tons and tons of tutorials out there. You can go on YouTube and learn about the basics. But like everything else in life, the basic is the basic. Very soon, you're going to need some more advanced information. And if you want to be productive, the basic is not going to hold water because a lot of the basic tutorials people show you is like, hey, let's create an array with fixed numbers, 1, 2, 3, 4. I mean, that has zero practical use, if you're going to be a developer. So I tend to start in the middle and work my way backwards if I have to, meaning I start with a real program and then I go and figure out what I have to do to understand the syntax, etc. And then I use all kinds of sources to try to find examples of how to solve the problem. So in this video, hopefully, you get to see a little bit of Rust, but you also get to actually create a workable program. And in this program, what we're going to do is we're going to mimic some of Excel-like functions, but we're going to actually use a library, what's called a crate in Rust, and set a reference to that and actually consume the information. And we're also going to use some terminal formatters like inquire crate. And we also look at how to call these different things and how you can actually execute a program within Rust. And hopefully we can get through it and it's not too terrifying. So, hey, make yourself a cup of coffee or brew, whatever you prefer, and let's get started. Okay, so my project was created using Visual Studio Code. So let me show you. This is what we're trying to do here. As you can see over here, this is the program right here. Now, in Visual Studio, there's a couple of things, and if you're familiar with Visual Studio, good. Otherwise, make sure you get some YouTube videos, etc., to learn about how to work in Visual Studio because not all of it is straightforward. There's a lot of things in here happening, and it's trying to cater to everything under the sun. But one thing, for example, is you can create files, and here you can see my files. You also see there's a certain structure here: VSCode, source, target, and then some cargo, and etc. So basically the way you can set it up is you're going to create a folder. The way you set it up is you go to your terminal, you create a new terminal, and basically I prefer, just to make it work, I usually use PowerShell, and that's my default here. But I noticed for this thing, it was a little easier just to use the git bash. So I select git bash as the terminal window. And I'm going to, in the description of this video, I'm going to give you a few references, how you can get up to speed on Rust, some tutorials that I recommend you probably look at. And also, a couple of videos that tells you how to set up a project in Rust, including using cargo, which is basically the main way that comes with the installation of Rust. In Windows, there is an MSI, installer that you can use, and for Mac and Linux, which you can find out how to do it in one of those videos I will put in the description to this one. So I'm not going to spend time on tell you how to install this and set all this up. Needless to say, I created this project using cargo. Cargo is the preferred method of using when you're basically creating projects in Rust. It's my understanding. So here you can see, now there's something called a TOML. It's a ridiculous name, Tom something, minimal language, something like that. Like Tom's observable minimal language, something like that. But it has an extension TOML. So when they say minimal language, I guess this is minimal. You have a package, you have a name for the package, you have a version, and all this is created when you use that cargo. It would automatically create this for you. And as you add crates, as it's called in Rust, which is basically like libraries in Python and so forth, like a library in R, what have you, it will add this to the dependencies. So as you can see here, I already put up financial, inquire, chrono, and colored. Go in and you do a search like docrs, and then of course you can drill into these different categories. There's something called a financial, and this one has these functions. So they're like Excel-like functions. And that's one of those references we're going to use. Notice this is version 1.1.5. And I think when you actually set this up, I think you do a command, if I remember right, you do something like cargo add, and I don't know if it was financial or just fin. I can't remember. Something like that. And it will add it in right here. But I already have it, so I'm not going to do it again. But you use this cargo add to do that. Sometimes if you need more, for example, I think for chrono, I think you might have to actually install it. So if that's the case, you can't just use cargo add. You have to actually say cargo install chrono, something like that. Again, you can try it out, and if you get errors, you can just try to install it and see if it solves it. But when it's all said and done, I also added this colored, which is another crate. So let's go and look at what that one looks like. So here is the financial. Here is the inquire, and notice it's for building interactive prompts on terminal. So in other words, it gives you a chance to actually, you can use a date select. So in your terminal window, you actually have like a date selector, like you would do in other GUIs, when you select the date and it drops down and shows you the day of the month and all that stuff. And you have text, you have select, which is like a drop list, and you have multi-select. And so this particular crate, as they call them, will allow you to set up some controls in your terminal. So that's why we use this one. I also imported or added to my project this colored one. And the reason I did that was because I want to basically color my screen with like the output, and maybe I want it in green, maybe the input in blue, and so on. So notice here, they show you a little bit of it. So here's a prompt. Okay, this is blue, and then you just set the color to be blue, right? So you can see, you can dig into this and get some ideas about how to use these colored ones. And again, you'll see some examples in my code as well. All right, so those are the crates that you want to be aware of. Now, let's move on and see how my code actually works. So what I'm going to do, I have already created a executable. And when you build this project, it will create an executable. You can say cargo run, and then you give it a name. But when you do the run, it will create it in your temporary space. So it doesn't become permanent, I think. I'm not sure about this, but I know maybe I'm mixing the two languages up, the Go and the Rust. But whatever it is, if I go to target here, you can see here, I have a debug folder, much like you see in C# projects, etc., and Visual Studio. You have some kind of thing, and then you go to debug, and then you see the output. Notice there's an executable here. Do you see that one? That's a binary format file, and is based on the name of my folder here. So I named it the same thing. There's some other files here, but we don't really care about that. So that's the kind of target we want to run. So if I'm going to actually run this code, before we look at the code, I have to first drill in to where that executable is. So the CD and where it sits is on the target, I believe. And then I want to CD into debug, right? Debug. All right. Now let's do an ls, list whatever's in there. And as you can see, sure enough, there is the Rust executable right there. All right, so let's clear the screen. On my machine, in the bash window, I write the word clear like this. And now it's back to normal. So if I want to run this now, I simply have to refer to the name of that file in the right folder. And I'm already in that folder. So if you look, it's called Rust_2024 executable. So let's try that. Rust 2024. Now, I don't know in Windows if it will actually open it, but I know like in Linux and stuff, it might do it like this. You also might have to do like a period in front of it, like to run it. If I try to run it like this, now let's see what happens. Yeah, I couldn't find it. You see that? Now, what if I do the same thing with an executable? Notice, couldn't find it. Now, the reason is in Windows, I have to put a dot, slash, and then the name of the thing. You see that? So when I do dot slash and name of the file, now suddenly it works. So notice what I'm getting here. And this is using the acquire package to show you these different functions. So I can move my up and down arrow like this, up and down. I can go sideways, but nothing will happen then. Let's do the present value first so I can follow my script. All right, so it's 0.10 and it is 5 periods. I want a payment of a -100. What happens here is it's really picky on the type of data type you're using. It wants a float, okay, because the payment is set up to be a float. There's different kind of floats, and we'll look at them when we get into the code. But take my word for it. In order to, if you just type it in like this, it'll be considered to be an integer, and it will crash because it's not a floating. To get a float out of it, even if it's 0, 0, just put a dot like this at the end. It will interpret as a float. And then the future value, I want it to be 0, but again, it's going to expect a float. So I'm going to say dot again. Then this one is a little weird because it says payment is due, true or false. Well, what happens if I type in true? Well, it doesn't like that for whatever reason. So the descriptor here is really poor. I should change it to yes or no, or Y and N. You see that? So if I say N, then it's going to be calculated as of the end of the period. So when I say N, here is the result. And it turns out to be present value is, and let's make it a little bigger so you can see it. It's $379.08. And I tested some of these functions in Excel and they produced the same result. So here you can see that's how you run this application. I'm not going to run a lot of these functions because it's kind of redundant, but let's run one more maybe. And let's pick a little more interesting one. Now the XNPV is basically when you have payments for your net present value. Your cash flows are at different points in time. So in other words, the difference between this and this is that you actually give the dates when it actually happened. So it calculates the time difference component as well as not just the cash flows. Okay, so there's a big difference there because it factors in the time. So when you have this type of thing, so let me find my XNPV script. As you can see here, here's my XNPV. And let me entered those values in. So the rate is going to be a 12%. Now the value, it wants to list the value, and that's why I'm using a different data type here, and we'll get back to that when I look at the code. If I knew it was going to be 5 every time, I could just make it into array. But here, I don't know. It could be another number after this. And notice they're all float numbers, dot, zero, etc. So those are the values, but now it wants dates, because at what point did you put this money in? At what point did you put this money in? Now, the regular NPV doesn't do this. It doesn't factor in the time portion of it. So in order to do that, I am actually producing some dates, and let me copy those and paste them here. So let's say I have a 2006 0101, and then 2007 33, 2007 07 04. Now I got this example from one of my finance books. So it's about Excel type of formulas, etc. So to double check it, I just use the same example. So here is basically, and maybe I'll list that book for you if you care. I don't think you care, but we'll see. Anyways, here is the dates where these cash flows happened. And then notice it comes back, it tells you the extended net present value is 16.8. The rate is whatever you put in here. The input values is in blue. The input dates is in yellow. And that's using that inquiry package that I showed you that is actually doing this coloring on the terminal. So that's how the application works. And now let's take a look at the code, and let me go through a couple of concepts in the code so you can get familiar with it. So in order to understand the primitive data types in Rust, I went to this site. And as you can see here, you can go to the documentation for Rust. Just do a search for Rust documentation, and eventually you end up here. So you can see this is the address to where I'm going. And what I'm interested in is to look at the different primitive types in Rust. So in other words, how do you figure out what data types to use, etc. So what I want to do then is I wanted to go and take a look at some of the primitive data types in Rust. So now I lost it here. So let me try that again. Rust. And let's go to Rust documentation. And let's go to the API. And let's look at primitive types. So here you can see them. So in order to figure out what the different things do, I won't cover all of these, but I'll cover some of those that I actually used, like the floats and the signed integers versus the unsigned. Okay, so let me take one step back here. And when you have an unsigned integer, you see like U16, U8, the type of unsigned integer, these can only be positive numbers. So if you try to load a negative number into a variable that is of type U8 or U16 or U32, etc., you're going to get an error because it doesn't allow it. It's an unsigned, meaning it can only be positive numbers. So if you know you're dealing with only positive numbers, you know, like age and so forth, you know, there's no negatives in age, right? Unless you date backwards like 1,000 years or how. But when we're talking normally, that's a positive number goes into these unsigned integer. And then you have the signed integer with the I in front of it. And those will have slightly less storage than the unsigned. And the reason is because it has to use 1 bit to store the sign. So it needs a bit to store the negative sign or the positive sign, because it can be both positive and negative. So that's the difference between the unsigned and signed. So if you drill into one of these, let's just take I16, right? Now look at this one. This is the data type, and it tells you this is the minimum size you can actually use. So a better version will be down here. You can see here's the minimum. And because it's a signed integer, you can also have positive values. Now here's the maximum. And if you look at this formula here, this is how you can find out how much space. So what I did was, I just created this spreadsheet very quickly, and I plunked in some of the formulas from that documentation. So, and then I put the number here. So 8, 16, 32, 64. I didn't want to go to 128 because I'm probably never ever going to use it. unless you're working in space or something, or astrophysics or something. But notice, here's the data type, and these are the signed ones because they have an I in front of them. So to figure out what the min and max here is, you use the formula. So it's a negative 2 raised to the power of 8 minus 1 is 7, right? So C9 is 8. So it becomes negative 128. And for the positive side, you do the same thing, except for you remove the negative sign. So it's 2 raised to the power of, and if you look at the formula, 8 minus 1 is 7. So it's 2 raised to the power of 7 will give you that number. So you can very quickly calculate the ranges. So in case you wonder how, if I have this variable, would it hold my number or not? Notice the 64, and again, this go back to memory management. I see it all the time in databases, and I'm guilty to a certain degree too. They use way over sized values for something simple. For example, if you have a sequence of 1 through 100, why on earth would you use a 64-bit storage? Notice the numbers here. It's way overkill. You should use the minimum one. So if it's only up to 100 and you know it's not going to be more, use an i8 for goodness sake. You're saving so much memory on your computer or computers, depending on how you work. So anyways, these are the sign types, and you want to be aware of when and where to use these types. These are the primitives. So i8 for very small values, i16 for medium kind of values, i32 for when you're getting into the millions, or billions, I should say. And of course, the 64 is dramatically higher. But notice the unsigned type. Remember, unsigned can only be positive. So here you only calculate the positive. And again, the formula is slightly different. It's 2 raised to the power of. So if you look here, 2 raised to the power of 8 minus 1. That's how you calculate that. And in case you wonder, in the documentation, well, you can just look and you can find the formulas here how to determine this. So I just wanted to sideline and show you this so you kind of understand how these are set up in these sizes. And I probably have some sloppiness in my code too. I probably refer to some way too big numbers that I need. I'm sure of it. By the way, there's one more data type I want to show you. It's not a primitive type, but it's yet another data type that I'm using. So I want to make sure I cover it. If you look at the side on a side here in the menus, click on macros, okay, and scroll down till you see vec. And vec stands for vector, okay? So when you click here, you got to get to this page. So let me just highlight a couple of things. The object, meaning an array, a dynamic array, is called a capital W, capital V here, vec. That's the storage form. So you can create a vector, but in Rust, there is a method of doing so, meaning it uses this vec macro. And if you look at the syntax here, you create a variable, let v equal to vec bang sign, and then some values. What this, in fact, is doing, this is a macro. This is not the data type. This is the macro that creates the data type. So when you see vec in small letters with a bang sign, that's the macro. When you see vec with a capital V in front of it without the bang sign, that is the actual object it creates, the vector it creates, the dynamic array it creates. So if you look here, you're calling this macro to create this dynamic array called a vector. So I just want to make sure you understand the difference here. Vec, bang sign, small letters, is a macro that creates a vector that will look like this. So I want to point that out to you so you're actually aware of how that works. Rust can be very tricky, and you're dealing with all the memory calls and references and pointers, etc. Now, if you want to play around with some basic Rust, you can go to this playground. So you just search for Rust playground, and you end up like here, and you can write some code and actually run it on the fly here. So what I want to just show you very quickly is some things that are specific to like vectors, okay? So let me show you a couple of things here. So I'm copy some text in here. Let me see if I can paste it. All right. So what happens here? Remember, this small vec with a bang sign is a macro. So you're calling this macro to create a vector. And this vector is going to be called v. So you use a let keyword for declaring variables. Some other languages like JavaScript, for example, you use var, etc. You can create constants and so forth. So you create a variable v. However, this by default, the way this is structured, once you load this variable, you cannot change it. And that's what's called immutable. It's an immutable variable. You cannot be changed after it's created. Now, if you're going to change a variable later, you have to make it mutable. And I'll show you that in 1 second. But so right now we're creating an immutable vector, v, and we use the macro to create the vector for us. Then I'm setting up a for loop. So notice, this is a reference pointer, and this is a reference in memory wherever that vector is being stored. And I think vectors are stored on heap memory. There's a difference between something called stack memory and heap memory. Stack memory is much, much faster than heap memory. In any event, here we are creating an immutable vector, and we are using a technique called borrowing. So we're going to borrow that vector and do something with it. And that's what we're doing here. We're borrowing the vector. This particular line here, the println bang sign, is simply a way of printing a line out to the console and add another new line character to it that is invisible. But that's what that does. It's very similar to what you see in Go, for example, which println. And you'll find println in a lot of other languages too. This is what is called a placeholder. You put these. Now, if I had 2 or 3 of these, for example, I could have item 2, I could have item 3, etc. I could have more than one here of these, right? And I could have text between them. Something like this, right? But the trick here is this is the positional character. So I don't have to print them out in the way they are listed here. I could, for example, say, hey, print number 2 first, then the first one, and then the second one. So you can do that too as well, because these are simply placeholders. All right, so I just wanted to show you that. So in this case now, we are simply going to be printing out one item, right? All right. And here, this particular question mark after has a specific meaning because it's still, it has to do with the print formatting. And if it can't figure it out because it could be a null value or something, sometimes you can escape the error or the warning you're getting by simply putting this question mark behind it. So that's what we're doing right here. So let's just run this and see what happens. I'm running this, and you can see over here, it's printed out 1, 2, 3, and here is the vector 1, 2, 3, which we printed out right here. Okay, what would happen if I remove this question mark? Well, let's try to run it again. Notice now I can't compile it. So what happens in you can see here, it's complaining about the standard library for the formatting functions, the display function. It cannot figure out because it doesn't really know what to do with it. And that's why you say use this question mark to avoid this problem. And that's what we're doing here. And once you put that question mark in, it works just fine. Okay, so that's the concept of borrowing. That's the concept of immutable. Now, let's look at borrowing again. But, okay, borrowing, what does it mean? Think about it in logical terms. When you own something, you own it, right? When your friend wants to use something of yours, he borrows it. Same thing here, okay? I'm the owner of the V. You want to borrow it, so you can set a reference to it here and still use it and look at it. That's fine. You borrow it from me. However, I own it. I'm the owner. Now, if you want to borrow, but you want to change it, if I let you change it, then you're getting into something called mutable borrowing. So let's see what that looks like. And again, the syntax is a little confusing, but I'm not going to dwell on it too much because it's very difficult material to explain very quickly. Here, I'm using the keyword mute. And what that will allow you to do is change the variable. So we got 1, 2, 3 here, but now I'm gonna make it so you can actually change it. I'm still the owner at this point. However, you are gonna borrow it. So you borrow my V, and the way the syntax works is you put the reference before the mute keyword here. And therefore you're gonna be changing the vector, but you use it like this. And this star item is really what's called a pointer. It's a pointer to this, wherever this gets stored in memory. And therefore, by referencing like this, you point directly to it, and you can alter it here. And that's what we're doing. And again, you got that same question mark. So let's see what happens when I run this. Okay, so it takes a little longer, and one of the reasons it takes a while for this stuff is because it has to create an executable out before it can actually display it. So again, it doesn't look very different, but that's the principle of borrowing and ownership on a mutable variable, okay? So the third thing I want to show you then, or final thing I want to show you, is what happens if I transfer the ownership. Okay, so let's see what that means. I'm not letting you borrow it now. I'm simply going to transfer the ownership. Again, you set up a variable, you call the macro to create a vector, 1, 2, 3. Then you're going to loop the vector. Notice there's no @ sign, there's no star pointer or anything here. It's simply, like this. And now, if I'm going to print this and run this, it runs just like before, 1, 2, 3. However, this loop here take ownership of the vector, the v vector, by including it in the loop here. So suddenly the ownership has shifted from here to here, okay? So I know it's a little tricky to get your brains around all this stuff, but if you come from a C language, you should be familiar with memory and the concept of pointers and so forth. Anyway, now that you've seen this kind of stuff and you're a little bit aware of ownership and borrowing, and what do we do all this stuff for? Well, remember, C++ is not a memory-safe language. Here, you do it this way, so you can only be one owner at a time here, and that's the kind of safety of the memory. This is the way Rust is doing it, so it never runs into issues, and that's why its compiler is really complaining about everything before it lets you compile your program. You're going to see so much error messages when you run your stuff, and you be whoa, it's all over the place. But it's done for purpose, and the error messaging in Rust is really outstanding. It's really good. You don't get away with anything, and you just can read into it to figure out how to solve it. So it's very good. But like I said, it's not for the meek. Rust is a pretty tricky language to learn. So you really got to want it, okay? All right, let's move on. Okay, so finally, let's take a quick look at the code here. And again, I'm going to make this available on my repository out on GitHub. So you can always study it on your own, and I don't want to spend too much time going through every little detail here, but let me just give you the gist of it. So you can see the code is not that long. Initially, in the TOML, as you remember, here are the dependencies: financial, inquire, chrono, and colored. You create a Rust main file here, like you can call it whatever you want, but you got to have only one main function, okay? So I call it main.rs. The extension for Rust is rs, okay? So right here, you can see in Visual Studio Code, I use in the dark mode. I hope that's okay. Let me close this guy. And I'm importing the chrono, the inquire, and the colored. And again, I'm not using everything from chrono. I want to use the datetime module, the UTC, and the time zone. Here, I only want to use text, select, and confirm. And refer earlier to earlier in my video, I went through some of this stuff in the acquire. And then, of course, the colored one is how you can color the terminal. So here's my main function. I'm creating a couple of variables here, options. This gray stuff you see is something that Visual Studio is showing you. Basically what happens here is that this is not hard-coded. I haven't hard-coded this. I haven't actually typed it in. So this is what's called an implicit conversion. And what that means is that Rust behind the scene, by checking this stuff, it will know, hey, this is a vector of strings. So therefore, it will implicitly when it compiles it will convert it into a vector of string. And this is not really a string. This is a little tricky in Rust. This is what I call a string slice. And the reason there's a difference between a string and a string slice is that a string will be stored on a heap memory. So back to all the memory stuff again. This, however, will be stored on a stack. So therefore, it'll be much faster. And this is a reference to wherever this is going. So this will be a string slice, okay? Here, you're calling a function or the macro vec that's going to create a vector. These are my input values. And if you remember when I displayed my application, I had a down and up to choose which function I want to run. So that's what that relates to. Here is a function that uses the inquiry select. And sometimes in here, you can see you just hover over it and you can see where it's coming from. Inquire, colon, colon, prompts, colon, colon, select. So this is kind of how you drill into the select struct inside the inquire prompts module. So as you can see, it's a public struct, POB, means that you're making it public. And then you have a select, and also notice it can have more than one type. And notice the message is a string slice. The options is a vector T, meaning whatever type you're choosing there, whether it's ints or unsigned or what have you. So you can actually hover over and find out more information about it. Here I'm creating a new message, as you can see. And again, this is the implicit conversion right here. Here you select the function, and this is being cloned. This object is being cloned. And these type of things gets a little unwary because you're using these prompt and unwrap to create. Okay, so let's look at this code a little bit. Now again, this @str is really called a string slice. And because you set it up like this, you're basically borrowing it, okay? It's an immutable reference to a string, and it's fixed length, and it's stored in the program's memory, okay? And it's light-weighted. It cannot be modified. And if you have a string, on the other hand, that would be something you own, and it could be growed. You can add to it. But it will be allocated on the heap memory, and it can be modified. So that's basically the difference between the string slice and the string, okay? It's how you treat it as far as ownership goes and how memory goes. All right, so if I don't want to cover everything here, but let's just look briefly at this function here, the basically main thing here, okay? I'm using the match keyword, and that's basically like a switch statement, okay? And I'm looking for like this. This basically means refer back to the function, okay? So what does that mean? Well, this piece creates a string slice of the entire function string. When I say the function string, I'm talking about this piece here. So this one creates a slice from there, and of course, the @ sign means a reference, and the ... inside the bracket there means the entire string, okay? So, okay, it's a little cryptic, but so the actual bottom line is that I'm collecting these guys to figure out which one to call as part of my switch statement. So whatever I selected gets compared, and it finds the right one here, and it will call that one to execute the code inside of it. So that's basically what it does here. Okay, so the next thing then is to see what does each one of these functions do. Well, let's just take this for example. I'm creating a variable of type f64, and if you remember, that's a floating point. I don't think I went through the floating points, but anyway, take my word for it. You can go and look it up in the documentation. So this is probably an overkill. This should not be a float 64. It should be smaller, maybe a 32. I think there's only two kinds, 32 and 64, if I remember right. So anyways, I'm creating these variables that goes into calculating this function. And here, this is the true false stuff. Remember the yes, no. And again, I'm using inquire Boolean. So that's part of the, actually the inquire thing. These are functions, I should say. Let me step back here. If you look at this, let's go through one of these. So let's go to the definition of this guy. And down here, you can see it. This is the function. And basically what it does, it simply uses the text. It creates a new text message, a prompt. And it uses what's called unwrap, parse, unwrap. So what does that mean? Well, let's look at the bigger one. Let's look at this one. So once you've seen one of them, you probably can figure it out. What does this do? Well, the first thing it does is that you notice that looks a little different is this dot map, bracket, S, colon, string slice, bracket, and so forth, right? So what does this mean? Well, not the bracket, what do I call this? Up this guy, whatever that is called. This plus the S plus this one, this is just the implicit conversion here. That indicates that this is an anonymous function, or sometimes called a closure in Rust. And it takes a string S. So this is like a dynamic function, almost like a lambda thing, if you will. And it uses the map, and it's going to basically map whatever that string is. First, it's going to trim it. And what does the trim do? It removes this white space from the beginning and end of the string. And also, if there's spaces and stuff, it removes that. Now, the parse attempts to convert that trimmed string into a floating point number. So that's what the parsing is doing. It will return either like F64 or an error, okay? So what does this unwrap underscore or 00 mean? Well, if there is a key error handling method in here, so if the parsing succeeds, then it will return the parsed float number. If it doesn't succeed, it's going to return a 0.0 as like this. So that's what this unwrap underscore or is doing. It's basically used a lot in the results and so forth. So funny thing in Rust is that I always laugh when I hear this because I've never heard this before until I start looking at Rust. When there's a problem, the program panics. It panics. So this is to avoid panicking. So, yeah, I always laugh when I hear that word, panicking. I wish all my programs were panicking. Anyways, so this is kind of what this one is doing, and then you just collect all the results afterwards. So it has a prompt that relates to the inquirer, and it has its own built-in error techniques. So expect means that you produce a message that happens. So all this stuff is basically setting it up so there's no problems when you actually create your output. And down here you can see I've created a date using the chrono package, and I'm using what is called a naive date. And you can see here what a naive date will be doing. You can read this information here. And also I'll do some formatting here so it looks kind of nice. Okay. So enough of this. If you want a more understanding of what this does, you're going to have to dig in and do some more research because it's just too time. I always way into this video much more than I wanted to. So that is the program basically, as you can see. And here I'm doing basically a check on this and see if there was any problems, any errors, because this comes back as a result set, as you can see. Here's the result. And it's either success, okay, or failure. And if you look at it here, you can see it's an enum, so okay, an error, and then it's T or E, so you can refer to the result, get the T, which is the okay, or the E for the error. And that's basically a switch statement here, and that's what that one does. And as you can see, here is the message you're printing out if there's an error, and you're passing in the error object that from this result. And of course, if there's okay, you're getting an F64 floating 64-bit return value, which will go in here. And therefore, you can print it out here, and you want to make it look bright green, and you want to bold, and so forth. So that's basically a lot of the code here. I think you have enough to understand most of this. It's not, there's a lot of details in here that is hard to explain, but it will take way too much time to try to go through everything. So I'll leave this up to you to follow up if you're interested in a Rust programming language. And that's pretty much what I want to cover in this video. Now I will make a video about the Golang, and I'll point out that language using a very similar thing. I will create a financial calculator there as well, and I will try to highlight it or make it pretty and so forth. But I will show you the difference between the Rust language like this and the Go language for creating these type of programs. So I hope you like this video. If you do, please give me a like, and it really helps for visibility so more people can see my videos. And consider subscribing to my channel if you like my content. Thank you so much. Have a wonderful day, night, wherever you happen to be in the world. We'll see you soon. Bye-bye.